In these next three problems, it takes a little bit more in-depth understanding of what each function grows and how fast it changes to really figure out the answer, because they're asking us, as x approaches infinity, which function becomes the largest. So as it goes forever to the right, which one's going to be on top eventually? And so maybe we could start by looking at a graph of these to kind of evaluate it. So the first one looks to be 0.7x squared minus 4. I mean, at least on the graph anyways, to the line is on top. And then 3x minus 1. And if we just did zoom 6 or graph that, let's just take a look at what this looks like already. And it kind of looks like they're about to intersect, so maybe if we hit the window and change the window settings, and let's make this a little bit more, we don't need to see the left side so much, maybe I'll make that a -5. The y min, again, I don't need to see, I need to see the top right half of the graph, so maybe I'll change the y max to something like 20 and graph it again. So again, I'm just kind of looking at this part over here is what I'm interested in. And sure enough, the quadratic eventually overtakes the line. Do you see how the quadratic is beginning with that intersection point is above? And so they're just saying as x goes forever to the right, which function is eventually on top? It's the quadratic. So the answer for this first one would be f of x. And I guess an invalid reason for that would be, let's even find the intersection point. If I hit second calc, you don't have to do this step. I just want to see where they meet though, to figure out what point does it overtake it. If you just hit enter a bunch of times, it'll find it. So when x is greater than 5.1, the parabola basically overtakes the line. So you can see that basically right here, from here above, the parabola or the quadratic is above the line. Alright, now we have a similar situation. We have a quadratic and an exponential. Initially, the quadratic looks like it's above the exponential, but again, if you had to kind of compare these in a race, if they're all positive, like they're all increasing functions for the most part, like a parabola is increasing and decreasing, but as you move further and further to right, the line grows the slowest eventually, the parabola grows faster, and the exponential should even grow faster than that. But let's take a look at that by looking at the graph of each of those functions first. So the first one would be x squared plus 4x plus 4. And the exponential function looks like it's 2 to the x minus 6, so 2 caret x minus 6. So I graph those right there, and let's just do zoom 6 to reset the graph. Okay, again, from what I can see on the graph, it looks like the parabola is still above it, but if I again go further up into that right-hand corner, so let's change the window here. Let's make the left-hand side a little bit smaller, maybe something like -3. I changed the window. The x max, let's make it 10 might be enough, but we can leave it, I guess we'll leave it as 10. Y min, I'm not really interested in too much of the bottom part of the graph, so let's make that -5. And let's make the y max maybe something like 40. I'm just making it much higher so I can see further up the graph a little bit. And y scale is just what it jumps by. I might change that to 5 and then graph it again. Okay, there's the parabola, and here comes the exponential. Okay, they still haven't met yet. It's still not high enough, but it looks like they're getting closer and closer together. So let me change this window setting again. Let's make the y min a little lower so I can see that line. It kind of was hard to tell which was the exponential and which was the quadratic. Maybe I should have left that at about -7. But the y max, maybe I need to make that like 100. So I can see higher up the graph, much further up the graph. Let's graph that again. So it's just a matter of finding a good window range. It's kind of hard to see it, and you just got to kind of look for one that fits. But you can see right here the exponential eventually takes off faster. So you can just have an understanding of exponentials without actually having to graph these to understand what's going to happen. But eventually, as x goes to the right, that's what it means. As x approaches infinity, as it goes forever to the right, the exponential will eventually overtake the quadratic. So in this example right here, g of x eventually becomes the largest as you move to the right. Now we have three graphs, and again, it's just a common understanding. The line's going to probably grow the slowest. The exponential eventually will grow the quickest as it moves to the right, and the parabola will grow in between those two. So it's kind of like in this one, without even doing this, the exponential usually grows the quickest. So I'm going to guess that it's g of x, but if we graph these and verify that it does actually become the top function, we can just type these in really quick. So my choices are x squared, 2 to the x minus 4, and it looks like 1/3 x minus 4. Okay, so if I graph these again, let's just choose a window. We're really interested in this right half anyway, so -3 sounds about right. 10, I can leave that maybe there. Yeah, these all look good. Let's just look at what this comes up with. There's the exponential, and it overtakes really fast, so we don't even need to go that high. So let's change it so it's a little bit more visible again. So -3, 10, we're all fine. Maybe -7 was okay. This was just seemed a little too high. Maybe 40 would have been enough for this one. So there's the exponential. And that line is still a little bit, maybe I can come down a little bit further, maybe to 35 and then bring the y a little bit up higher. So if I had changed this window right here, maybe I'll make that a -10 and make that a 35, just so I can see all the pictures a little bit better. So now there's the parabola. Here comes the exponential, and it does overtake and go higher, and then there's the line right there. It's kind of hard to tell, but they're all squished together. So they're wanting to know which one of these functions eventually ends up on top as you move further and further to the right. And you can see it, the exponential always takes over eventually. Alright, let's look at these next ones. Now we're going to do the same kind of thing, but looking at a table. It says a partial set of values is provided for two functions in each problem below. For all x greater than 0, which function would most likely be greater? If the greater function changes, determine the appropriate intervals. So we'll be looking at the m of x and the w of x values to see which one's larger. And so when x is 0 for both functions, I'm only going to the right of the 0 or whatever, I have 1 and 2, and so between 1 and 2, 2 is larger, so I'll underline the 2. Between 2 and 3, for x equals 1, you see x equals 1 right here, 2 or 3, 3 is larger. And again for 2 and 2, we have, the choices are 3 or 6, 6 is larger. 4 or 11, which one's larger? 11 is larger. 5 and 18, 18 is larger. And 6 or 27, 27 is larger. So at least it appears, based on the table, or based on the values, that if we compare m of x to w of x, w of x will be greater for x greater than 0, because we were only asked to compare that for when x is to the right of 0. Alright, so again, we could also analyze this by looking at doing a scatter plot to see what kind of functions we have if we wanted to. That might be interesting to do. So again, I'm just going to create a scatter plot. To do that, you'd just go to Stat, Enter, and you'd highlight that L2 and press Clear Down to clear out the old data, and then Clear Down, and then I could type in the data really quick. So you can see I just typed in all the x values. Now I'll move it over to the L2 and type in the m of x values. So 1 is the first one. So now I just typed in, so basically the first table is 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, and 5, 6. Right, they're all the same things. And for L3 we can just use this, since the exact same x's again, we'll just type in the corresponding y values or w of x values that would go here. So 2, enter. So I type all these in, and now I can tell my calculator to actually plot these points to kind of see what the graph might look like if you go to stat plot. So I could go to second stat plot and go to plot 1 and turn that on and use the dots right there. So the first choice, and L1, L2 is that first graph, and we can use the marker just like it is, so that looks great. Then I'll move it back up to the top and go to plot 2, and again I'll turn that one on, except for this one's going to be a different, again that first choice, that type, would be the first one. And then for my X list, it's L1 again, so I hit second L1. But my Y list this time is, remember we put it in the third list, would be L3, so I have to hit second L3. And then I probably would change my cursor to something different, so the marker, so I can tell the two functions. So the first function is going to be a square, and the second will be a plus. And then finally, if I press zoom, zoom stat, which I think is zoom 9. Oop, went too far. There it is, zoom 9. You can kind of see the two different graphs, and that equation in there is just from the previous. Maybe I should have cleared out my equations before I plotted this. Let me clear out that that's from the previous examples we were working on. And so you can see it looks like we have a parabola, because this one's taken off, and a linear function right there. And so definitely it looks like if that's the case, then we could even say that w of x might be greater for all values of x. Alright, let's try the next one. Alright, again, we could kind of verify what it is by looking at first or second differences of these y's, but all we need to do is figure out which one's greater. Alright, so between on x equals 0, -2 or -3? Well, it's better to owe $2 than it is $3, so -2 is larger. Alright, between -1 and -2, -1 is still larger. Alright, for x equals 2, they're actually equal this time. So that must be where they intersect each other. And then between 5 and 6, 6 is larger. Between 13 and 13, once again, they're equal again here. And then between 29 and 22, 29 is larger. So it looks like we've got some places that are definitely interesting if these are continuous. Okay, so there are definitely some regions where f of x is greater, and there are definitely some regions where p of x is greater. So let's describe this using terms of x. So you can see basically, since we're only going to start from x greater than or equal to 0, that means from x equals 0 all the way up to 2, basically this function was bigger. You can see I underlined the bigger numbers. And then again it was bigger when I got over to 4 and went on to forever that way. Because I know it stopped at 5 for the table, but that doesn't mean the function stopped. So the function would probably continue onward if this is just a partial set of values. So we could say that f of x is greater than p of x when the following happens. And I think the best thing to do here is we're going to try to list this with or interval notation. We could say from basically from 0 up to 2 for the x values, and from 4 to infinity, that's when the f of x is bigger. You can see I underlined the areas where this was bigger, and then I looked at the x values to describe that. You could also say that with set notation if you wanted to, and we could say when 0 is less than or equal to x, which is less than or equal to 2, or when x is greater than 4. So either way is correct. You use interval notation, which is on top, or set notation, which is on bottom. All right, now it's the other way around for that middle region right there. You can see for that middle region, basically from here to here, from between 2 and 4, this function was actually bigger. So let's write that. P of x is the larger function, or greater than. And if we look at that, basically I guess I should use purple again, from 2 to 4. So if I write that in interval notation, that would be 2 comma 4. If I write that in set notation, which would mean the same thing, just a different way of writing it, would be 2 is less than x, which is less than 4. So you're trying to describe where is it bigger. And you can see that the top function was bigger here to here, and the bottom function was bigger from here to here. And really quick, so you can see that, I could create a scatter plot for you of each one of those. Let me just do that so you can see it, the difference in the functions. So again, I'd go to Stat, Edit, and clear out the old data. And then I'm going to pause here and enter all the data in. Okay, you can see I just put all the x values are the same, 0 through 5, and then I put, in the top one I put -2 and all this, and then L3 I put all of this data. And now if I press zoom 9, we can quickly see a scatter plot. It's not too easy to see, but it does look like you can kind of see where they overlap each other. Maybe if I can make the window a little bit closer, so the Y-max, maybe make that as high as maybe 28. We'll probably chop off one of the points, but I guess it's kind of hard to see in this one, but it looks like an exponential and a quadratic, which we could verify with the differences. It didn't help as much as I thought it might with the scatter plot. Let's try the next one. Maybe it'll get a little easier as we try a couple more of these. The formatting looks like it got messed up right here, so let's do this carefully. That should have been a 0. Okay, so on these problems we're going to do the same thing. We're going to look at it as x equals 0, which one is larger. So between 5 and 0, it looks like, in this case, 5 is larger. At x equals 1, is 9 or 1 larger? 9 is larger. At x equals 2, is 13 or 4 larger? 13 is larger. At x equals 3, is 17 or 9 larger? It looks like 17 is larger, again. At x equals 4, is 21 or 16? 21 is larger. And finally, at x equals 5, is 25 or 25 larger? Actually, that's kind of interesting. Neither one, they're both equal at this point. So we're going to have to see to kind of figure out, estimate what would happen after this. If maybe we found the next point, for example. Let's do that. So if I look at the first differences here, 5 to 9, how far? That goes upward, it looks like by 4. From 9 to 13, again, that goes up by 4. You can subtract the 2 if you need to. It goes up by 4 again, goes up by 4 again, and it goes up by 4 again. So I can assume if I went to one more value on the table that it would continue increasing by 4, so it would go to 29. Now let's see if we can figure out the same thing for the bottom table. Alright, for h of x it goes up by 1. 0 to 1 is up by 1. From 1 to 4 it's up by 3. From 4 to 9 it's up by 5. From 9 to 16 and that's up by 7. and from 16 to 25 that's up by 9. So it's definitely not linear, but I can kind of see the pattern. It looks like the second differences are the same because that would be 2, 2, 2, and 2. That's probably quadratic, but I can make a conjecture that if I go to the next one, it'll probably go up by 11 if I follow that pattern. So here it'll be 6, and if I say 25 plus 11, that would be 36. So it does look like at this point the bottom function overtakes the top function. So let's see if we can describe that again like we did the previous ones. All right, so we're saying basically the top function is bigger to start with from 0 all the way up to 5, and that's where they're equal. So that's why when I'm going to write this, I'm going to say g of x is the bigger function, or bigger than h of x. And again, assuming these are continuous in this partial set of values, I'm predicting that I would say that it's bigger all the way from 0 up to 5, which that's correct in interval notation. If you want to write that in set notation, you'd write 0 is less than or equal to x, which is less than 5. But after 5, it looks like h of x becomes bigger. So let's write that. So h of x becomes bigger than g of x for everything after 5. You can kind of see basically if I'm writing that, I would say starting from 5 and going on to forever. So in interval notation that might look like this. We might write from 5 all the way to infinity. It looks like this one's going to be bigger because it started growing faster. And an interval, that's interval. In set notation that would be the same thing as saying x is greater than 5. All right, a little trickier because we had to kind of go past to figure out where the other function overtook which function. So let me underline where I think again. So all of these, that function was larger right up to there, and then from basically 5 and over, the bottom function became larger. All right, let's try one more again. So let's underline which ones are bigger. Right? So when x equals 0, 0 is larger than negative 1. When x equals 1, 1 is larger than 0, so 1 is still larger for this one. When x equals 2, they're equal, so that's when they match up. All right, and then I have a choice at x equals 3, 7 or 8. 8 is larger. At x equals 4, 15, again, it looks like they're equal again. And then from 34 to 24, which one at x equals 5, 34 is larger. So the top function is larger from here to here. And the bottom function is larger from here to here. So we just need to describe the x values of those. So hopefully this is becoming a little bit more easy as you kind of see this process. So q of x is larger than t of x, so it's bigger whenever we're starting at basically 0 and up to 2, and then from 4 on to forever, which we're going to call infinity. All right, so the way we'd write that is we would say that from 0 to 2 union 4 to infinity. A little tricky, but possible. All right, and then if you want to write this in set notation, we'd write 0 is less than or equal to x, which is less than 2, or x is greater than 4. Interval notation is a little easier to write for this one. But in the middle, t of x was bigger. T of x was larger than q of x in the middle. So you can see this region right here in the middle, from 2 to 4, this one was bigger down here. So from 2 to 4, and an interval notation, or that's interval notation, and set notation that would be 2 is less than x, which is less than 4. You should sandwich in the middle. I realize this is a little bit complicated and tricky, but please don't hesitate to ask your teacher for additional assistance before taking the quiz if you need more help with these.